over to solid edge. So on screen you see that I have a fan blade that was scanned, and this is the kind of data, this is how it will come up inside of Geomagic Essentials. You already have a polygon, and in many cases you don't really have to do any cleanup, but I left some of the data to clean up so we'd have a little bit of time to demonstrate how I would remove areas and repair the mesh before extracting CAD information and sending that over to Geomagic Essentials. So as you can see, I put the fan on top of this sphere. So if I want to remove that bottom area, I can just look at it from the side, and I can grab tools from on the right hand side over here. In this case, the lasso tool, and then I'm going to change it over to select through. Now with this, I can come in and just window in and select through, and you'll see that it will go all the way to the other side. And then if I just hit delete, I can remove those areas. And if I want to do it again to get a little bit of that edge, get a little closer, I can do that. So if I just come in and select and then hit delete there. There's a few different areas around the part where there's some defects. What I like to do is run what we call the mesh doctor first, because what that'll do is it'll correct some stuff automatically and make less work for me. These 7 checkboxes here on the left hand side are 7 different categories of problems that we find wrong with meshes that are scanned, and if I hit apply, it'll automatically repair those. But if there's any reason for me to look at those individual areas, I can hit this walkthrough mode, and it'll take and show me each one of those areas if I wanted to see it and evaluate it and possibly edit it on my own. So if I come over and I hit apply, the software will automatically repair all those areas on the mesh for me. Now you will notice that there are still some holes. Those green boundaries are showing that there are some hole areas that we can repair. So the next step after this mesh doctor finishes is then taking the data there and filling the holes for those green boundaries. So if I just give it a second longer here, it will finish repairing those areas. And you'll see it'll have all zeros there. So now if I just look around, you can see that there's a couple of holes. So if I come over to the fill single tool, up top here, there are 3 different filling algorithms to the hole fill tool. And then below there are 3 different approaches to filling. So filling the complete boundary, filling part of the boundary, or bridging the boundary. And then up top, it's the method that it's going to use to make up those missing triangles. So if I just click on a boundary, you'll see it'll automatically fill using that curvature-based method. Curvature-based method is probably the easiest to start out with, and then they have a tangent fill and then a flat fill. So flat fill is kind of obvious. It's going to try to cap off a hole with the flattest approach possible. And then with the tangent, what it does is it tries to maintain a nice smooth boundary edge tangent fill, but also maintaining a nice flat, less curvature approach to the fill method. And then this is an example of a fill partial. So you can come around and you can select from and to points and then select the side, and you'll see that it fills that boundary. And then on the bottom, if you wanted to mess with these, you can also do some fill partials here. But it's not necessary to fill everything because we're not really going to use all this. I just point out that these tools are here in case you need them. So after I get done hole filling, I almost always make sure that I run Mesh Doctor one more time. And there's a chance that it will find a few different areas with the hole fill. And then I go ahead and run that. And it should only take a second when you run it after you've finished hole filling just to repair any twisted triangles or anything like that. So now we have a data set that I want to extract geometry from. But before I can do that, if I click on the widget down here, you'll notice that the part is square, pretty square to the world axis. But if I come over to display and turn on the world coordinate system, you'll see that the coordinate system is way over here. So this is far away from the world coordinate system. So what we need to do is align this object to the world coordinate system. And with a fan blade, what I typically use is the axis, the central axis, and maybe the top plane. And then a lot of times I will grab one of the impeller blades and then fit a point there to index it. So I'm going to go ahead and create that geometry, and I'll show you how that works. So if I come over to model, what I'll do is come over and create a line based off this first option, cylinder axis. So you can come in and use the same tools that we use for selection, the lasso tool, but make sure that you turn off select through and toggle it back over to select visible. So you can window in areas like this to select that outer cylinder to create a cylinder axis. But what I like to do is use this option right here, this crease angle tool. What this does is when I click and hold with my mouse and drag up on screen, it will select more and less data. So you see it went all the way around and essentially grabbed all the faces that I want to use to create a cylinder axis and create that. So if I just hit next and OK, we just fit a cylinder axis there. Now the next step is to put a plane on top. So the top surface isn't as well defined because it's a pretty sharp, small little landing area. So what I like to do is I'll grab that lasso selection tool and I'll just click some areas on that top surface and do it this way because there's not enough, there's so much curvature there. There's not enough for that other method to work. And then this will give me enough averaging all the way around the outside that I can get a pretty good plane. Not only that, when I do the alignment here, I'm going to use that central axis as my main axis anyway. So that's going to be the primary axis of alignment. What I do now is if I right click in the open space on screen, you see that we do put the shortcuts for plane and cylinder. So if I click the plane, I can hit apply and you'll see that it best fits a plane to that surface. So then I'll hit apply and OK. Now, if I want to intersect those two, the axis and the plane, I can come over to point and you'll see plane and line. And then I can actually select that plane and the line that I created and then create a intersection point there. And the reason why I did that is I'm going to come over here and select a little bit of the tip there. And then I'm just going to say to fit a centroid point. And this is just to give me something to clock it to. I could use that. I could fit a line there if that line was straight. But in this case, I'm just going to use that point. And in this instance, I'm going to grab that point and come over to a 2-point line. And you can see I can click the from and to, and then hit apply, and it creates a line there. So there, I essentially created enough geometry to create a alignment. So now, if I come over to my tools and click align to world, the top is all of the things in the geometry already. So the X, Y, all these planes and axes, and even the origin. And then the floating is all the geometry that's on my model. So what we're going to do is we're going to click on that center point and the origin and create a pair. And we will do that one more time. We're going to create a center point and the origin. Actually, I think that's the issue is I clicked the line. So let's do that one more time here. So click on the point, the origin, create a pair. So now we locked in the wrong point. So I'm just going to go ahead and delete that one. So I clicked point 2. So if I click on point 1 in the origin and create pair, now you'll see the coordinate system is sitting on top of that axis there, exactly where we created that point. Now what I'm going to do is square up that axis to the other two pieces of geometry there. So now what I'm going to do is take that line, and I'm going to say align that line with the y-axis, and it'll square that up. And then now, in order to clock it, I'm going to align the x-axis with my other line, that line 2 that we created, and it will square that up. And you see, since these stack on top of each other, the point, then the axis, and then that line, you see that those lines it's not locking those two together, it's only rotating it until it matches. Now when I hit OK, you'll see that it squares up the alignment of this part, and you can see that it's aligned to the world coordinate system.